gives you a very flexible syntax to iterate on multiple collections at the same time. First, let's consider a conventional for each. You have our vector, that is a list of strings with foo, bar, and beer. And we have our result, that at the start is an empty string. And then we have a max, that at the start is just 0. And we declare both of them var, so that inside of the for we can update them. And then we do for myElem in vec. MyElem there is just declaring a new local binding. So for myElem in vec, we do something. Result plus plus equal myElem. We take the current value of result, we sum it with the current content of myElem, and we put the whole thing into result. Result is a string, and this is a list of strings. So plus plus is the concatenation of the strings. And so in this way, at the end of our iteration, results will contain foo, bar, beer. And then for max, we do max colon equal. That is the way in 42 you update a local variable, not just equal, but colon equal to help distinguish it. So max colon equal max.max myElem.size. So we take the size of all our elements and we compute the max starting from 0 over and over again. In this way, at the end of the iteration, we will have the length of the maximum word in our list of string. So this is pretty similar to what you had in most other programming languages. However, in 42, we can iterate on multiple collections at the same time. So we can have something like this, where we can have our RS, that is 1, 2, 3, our AS, that is 10, 20, 30, our BS, that is 100, 200, 300, and then we can do for A in AS, B in BS, var R in RS, R colon equal R plus A plus B. That is, we are iterating on all of the three collections at the same time. So we take the first element from the first, the second, and the third, the second element from the first, the second, and the third, and the third element from the first, the second, and the third. Plus, the third collection is iterated in var mode. This means that we can update the local variable R with a new value, and this change gets propagated inside of the list. So that at the end, if we check the content of the list, we will see 111, 222, and 323. In this example, the true lists have the same size. What will happen if they have a different size? 42 allows for the collections involved in a multi-for to coordinate with each other to decide what to do if there is a length mismatch. On default, in AdventOfCode, they will all throw an error. There are a bunch of techniques to change this behavior. The simplest solution is just to use vals with some boundaries, so that we are not going to iterate on the whole collection, but just on the little part that is going to have the right size. For example, here I'm iterating on A in AS, B in BS.vals from 0 up to AS.size, and var R in RS. That is, we expect RS and AS to have the same length, and BS could be longer, and we are cutting it to the length of AS. Or, if you prefer to think about which are the cases that are going to go in error, this will give error if BS.size is less than AS.size, or the size of AS and RS are different. Here we show that it's very easy to skip the first element. So here, for A in AS.vals1, we'll start from the position 1 and go up to the end. B in BS.vals from 1 to AS.size is going to skip the element in position 1 and is going to go up to AS.size. That is, you can think this as skipping all of the extra elements of BS that are out of the size of AS. Using a feature called views, we can be even more expressive. For example, here in line 1, I'm making nView as a view from a list of numbers. And I get it by doing collection.view num.list. And then I specify what are the attributes of my view. So here I'm specifying .cut. A cut view doesn't insist on completing the iteration. It's okay to cut the iteration in the middle if the other collections doesn't have enough elements. To see an example of our cut view in action, we can have a main where we have xs as a list of numbers, ys as a list of numbers, and we are not telling you how long are those lists, and then we do for x in xs and y in n view of ys. And now we're going to have an iteration that is exploring all the elements of xs and enough elements of ys until there are elements of xs available. And of course, this will fail if the size of xs is bigger than the size of ys, because our cut iterator is happy to stop the iteration, but doesn't have information on how to continue the iteration after the elements have been all processed. Cut views are very convenient when you don't know which of the two lists is the longest and you just want to iterate until both of them have elements. So if you write for x in n view of xs and y in n view of ys, you are going to iterate until any of the two have elements. If you are expert in functional programming, you will know that this is just the behavior of the zip function. If you are accustomed to functional programming and you have used the zip function without thinking too much about the detail, this may be the first time that you are realizing that when you iterate on multiple collections, something has to happen when the length is different. Another kind of view is the more view. So we can have our n view m for more and do collection.view of num.list.more, and now we get a view that knows how to continue indefinitely. And so when we create our view, we also have to provide the value for more, for what to do if we try to iterate outside of the boundary of the original collection. So, in concrete, if we write for x in xs, y in n view m of ys more equals 30 num, we get an iteration that is going to explore all the elements of xs, because we don't put anything fancy around it, so it's going to be the default, so all the elements of xs, and then all the elements of ys, and if we get out of the boundary of ys, no problem, we can just generate more elements, and they're all going to be 30 num. If we put our more view on top of both xs and ys, we will then get an iteration that will continue until any of the two collections have original elements. And if needed, one of the two sides can provide the default value when more values are needed. Finally, you may wonder how more views and cut views interact. So let's try to use them together. Here we have for x in our cut view n view of xs, and y in n view more of xs with more 30 num. This will actually behave exactly like the case in line 19, because a cut view is going to consume the more elements. Next time, we are going to unleash the true power of the slash.